Lesson 3-4, we have one more lesson that's basically review of what we did with equations, the same thing working for inequalities. So like I have said before, if you want to skim through this video, you can get the problems done at the end. If you want the reinforcement of watching each step, then please do it that way, whatever's going to work for you. Now, problem 1 on page 186, using more than one step. I'm going to let you take a look at that. I will walk you through got it number 1 on the top of 187. Get those problems in your book and we will go through them together. Letter A gives you negative 6a minus 7 less than or equal to 17. Well, first get the 7 to the other side of the equation. Negative 6a less than or equal to 24. Now we're going to have to divide by a negative 6, which means that after we're done with the dividing, we need to flip our sign. A is greater than or equal to negative 4. Let's check our solution. What happens if I choose 1? I like 1. It's easy to work with. Negative 6 times 1 minus 7 less than or equal to 17. And working through the steps. Negative 13 less than or equal to 17. It sure is. Let's go on to letter B. Negative 4 is less than 5 minus 3n. First step, let's get the 5 over to the same side as the 4, which gives us negative 9 is less than negative 3n. We have to divide by a negative again, so don't forget to flip the sign. 3 is greater than n. Check our answers. Anything greater than, the other way you might have written this is n is less than 3. So any number less than 3 should work. What happens if n's equal to 0? 0 is easy to work with. Is negative 4 less than 5 minus 3 times 0? Only on days ending with y. Alright, letter C. 50 greater than 0.8x plus 30. First, let's get the 30 and the 50 on the same side. 20 greater than 0.8x. Divide by 0.8, and it's not negative, so the sign stays the same direction. 25 is greater than x. The other way to write this, x is less than 25. Check it. Any number less than 25 should work. How about 20? There's my setup. Working through the math. And there's the answer. Is 50 greater than 46? Absolutely. Move on to problem 2. So problem 2 is a pretty good example of something you might actually need to use in your real life. You have 42 feet of fence. You want to fence in a garden that's got to be 12 feet wide. How long can you make your garden? Well, you know the width is 12. You know that your total perimeter cannot be more than 42 feet. So let L equal the length of the garden. 2 times length plus 2 times 12 is less than or equal to 42. Ta-da! The length of your garden can be 9 feet or less. Similarly, got it number 2, it's the exact same problem, just some different numbers. So you set it up, then check your work with mine. Alright, let W equal the width of this banner. If 2 times the width of the banner plus 2 times the length of the banner has to be less than or equal to 48, because that's as much material as we have. Why do we have these 2's here? That's right, because it's perimeter and there are 2 of each of those sides. Alright, 2w plus 36 less than or equal to 48. Ta-da, moving on. Your width less than or equal to 6 and more than 0. You can't have it be less than 0. It doesn't work, at least according to the rules of physics of our universe. Problem 3. Distributive property. You knew it would come back at some point, or you should have. And another aggravating multiple choice. Do you know why I don't like these multiple choice problems? It's because if you were taking a test, I would never have you solve this using real math. I would have you take each of these answers and see which one worked. So they're not helpful. Let's take a look at got it number 3, which is not multiple choice. What are the solutions of that inequality? And check them. So write it in your book. Let's solve it. Here's our problem. Looks a little ugly, but it won't be so bad after we distribute. Remember, we have to multiply negative 2 times 4m and also negative 2 times 7. So we work through the distribution, then we combine like terms on this side, then we combine this like term on that side, and now, remember, this was a minus 8m, so we end up with negative 8m. If we divide by negative 8, we have to flip the inequality. So negative 3 is greater than or equal to m. And check the answer. Well, what if m is exactly equal to negative 3? Then I substitute negative 3 in for m, and we end up with 15 less than or equal to 15. Why, yes. Yes, it is. Last but not least, number 4. Okay, so I lied. Number 4 is not last, nor is it least. Again, you've seen this already with equations. When there are like terms, when there are variables on both sides, you just have to combine them. You've seen this. You've done it. Move on to got it number 4. Let's try it ourselves. So letter A, here's our inequality. We've got terms with b on either side. Since this is a negative 2b, I'm going to start by adding 2b to each side. It would be just as correct to start by subtracting 3b from each side, which kind of gives away another answer you're going to need in a minute, but that's okay. 5b plus 12 greater than 27. Subtract 12 from each side. 5b is greater than 15. Divide by 5, it's positive, so we don't have to change this. b is greater than 3. And I'm checking it again. What happens if b is equal to 10? Another easy number to work with. Well, I plug in 10 for both of the b's, and I end up with 42 is greater than 7, which does work. Now, for letter B, again, they want you to be thinking, not solving. What they're asking you about, let's go back to the book, is this problem that they did in the book. They chose to subtract 3n from both sides first. Would it have worked the same if they had subtracted 6n from each side instead and combined them over here? You can test it out if you would like to. I'm going to go ahead and say yes, it would have been the same. So number 5, the top of page 189, this is definitely the last one. I actually have a question about this. They're talking about inequalities with special solutions. Some inequalities are never true, which we saw with equations, and some equalities that are always true. And I want to know why they don't call those identities like we did when they were equations. So anyway, they give you an example here. Letter A, 10 greater than or equal to 10 is always true, so the solution to this is any number. Maybe it's not an identity because the solution is any number. I don't know. I'm going to look into that, I think. And then what are the solutions of this equation? Well, this equation is never true, so it has no solution. And to round out your day, they would like you to find the solutions for each inequality. Just a hint, in case you didn't pick that up, one will have no solution, one will always be true. Which is which? So, letter A looks like that. I combined first the numbers without variables, I should say the terms without variables, and then I ended up with 10 is less than or equal to 0, which is never true, so 5A has no solution. Let's try 5B. I still need to see your work, even though you probably know what the answer is. Looks like this. Combine the x's on this side, so you end up with 6x. Then start combining the numbers, and this time you end up with 6 is greater than or equal to 0, which is always true, so for all real numbers, that will work. The last thing I'd like you to do, so in your homework book, you should have all the got it problems written down, and you should also do the lesson check on page 189. Won't take you very long at all. That's it.